Space is vast. It's an endless expanse that stretches beyond our imagination, filled with countless stars, galaxies, and celestial wonders. It's easy to think of planets as lonely wanderers, forever fixed in their orbits, silently circling their stars in a cosmic dance that seems eternal. But the universe is a dynamic place. Things change, stars explode in brilliant supernovas, black holes devour matter with insatiable hunger, and sometimes planets collide. These collisions are rare, but they are a testament to the ever-changing nature of the cosmos. The distances between planets are immense, often spanning millions or even billions of kilometers. Yet despite these vast separations, collisions are not impossible. The gravitational forces at play can bring these celestial bodies together in a dramatic and violent encounter. When they do happen, the consequences are spectacular. The sheer energy released during a planetary collision is beyond comprehension. Imagine the energy of 1 billion nuclear bombs unleashed in an instant. That's a planetary collision. The impact can send shockwaves through space, altering the course of nearby celestial bodies and creating a cascade of cosmic events. These events aren't just destructive, they're also creative. The debris from such collisions can coalesce to form new celestial bodies, giving birth to moons, asteroids, and even new planets. They can reshape solar systems, birth new moons, and even spark the ingredients for life. The intense heat and pressure from the collision can trigger chemical reactions, potentially leading to the formation of complex organic molecules. So let's journey to the outer reaches of a distant star system. Here in the cold and dark expanse of space, we can witness the incredible power and beauty of a planetary collision. Let's witness the collision of an ice giant and a gas giant. As these two massive bodies converge, the energy released will be a spectacle of cosmic proportions, a reminder of the dynamic and ever-evolving nature of our universe. Far from the warmth of their stars, we find the enigmatic ice giants Uranus and Neptune. These distant planets reside in the outer reaches of our solar system, where sunlight is but a faint glimmer. These planets are behemoths much larger than Earth. Neptune, the furthest planet from the Sun, is about 17 times the mass of Earth, while Uranus is about 14 times as massive. Their immense size and mass make them fascinating subjects of study. They are shrouded in thick atmospheres of hydrogen and helium, creating a dense, gaseous envelope. But what lies beneath these swirling clouds? The mysteries of their interiors are still being unraveled by scientists. Ice giants are not balls of ice like you might find in your freezer. Instead, their name comes from the icy materials that make up their composition. These planets are composed of heavier elements and compounds. They are made of water, methane, and ammonia, which exist in various forms throughout the planets. These substances contribute to the unique characteristics and behaviors of the ice giants. These substances are compressed under immense pressure, creating conditions unlike anything found on Earth. The extreme pressures and temperatures inside these planets lead to the formation of exotic materials. They exist in exotic states like supersonic water, which acts like both a liquid and a solid. This state of matter is a result of the intense pressures and temperatures found deep within the planets. Uranus and Neptune are our solar system's ice giants. Their unique compositions and distant locations make them intriguing objects of study for astronomers and planetary scientists. They appear blue because methane in their atmospheres absorbs red light. This gives them their characteristic blue hue, which is one of their most striking features. These planets have rings and many moons. Neptune has at least 14 moons, while Uranus has 27 known moons. Their rings, though not as prominent as Saturn's, add to their mystique. They are mysterious worlds, still not fully understood. Despite numerous missions and studies, much about Uranus and Neptune remains unknown, making them some of the most intriguing objects in our solar system. Gas giants are the true behemoths of planetary systems. Jupiter and Saturn dominate our solar system. These planets are mostly hydrogen and helium like our Sun, but they are much cooler. Deep within gas giants, the pressure is unimaginable. Hydrogen becomes metallic. It acts like a liquid metal. This creates powerful magnetic fields much stronger than Earth's. Gas giants often have swirling storms like Jupiter's Great Red Spot. This storm is larger than Earth and has raged for centuries. These planets are dynamic and ever-changing. Imagine an ice giant, a blue-green world of frozen volatiles drifting through space. It's on a collision course with a gas giant, a swirling behemoth of hydrogen and helium. The gravity of the gas giant is relentless. It pulls the ice giant closer and closer. The initial impact is cataclysmic. The atmospheres of the two planets collide. Shockwaves ripple outward at incredible speeds. The ice giant's icy mantle begins to vaporize, creating a vast cloud of superheated steam and gas. Section 5, Cosmic Chaos: The Anatomy of a Collision. The collision isn't a single event, it's a drawn-out process of destruction and creation. The ice giant plunges deeper into the gas giant's atmosphere. Tidal forces tear it apart. Fragments of its core, composed of rock and metal, rain down towards the gas giant's core. The gas giant's atmosphere is superheated by the collision. Temperatures soar to millions of degrees. The intense pressure and heat trigger nuclear fusion. For a brief moment, the gas giant becomes a small star, shining brightly in the darkness of space. Section 6. Fire and Ice: The Dance of Elements. The collision is a cosmic dance of elements. The ice giant's water, methane, and ammonia mix with the gas giant's hydrogen and helium. New molecules are formed in the intense heat and pressure. Some of these molecules are organic, the building blocks of life. Could such a collision billions of years ago have seeded our own solar system with the ingredients for life? It's a tantalizing thought. Section 7. A New Order: The Aftermath of Collision. The collision eventually subsides. The gas giant, now scarred and swollen, settles into a new equilibrium. Its atmosphere is enriched with heavier elements from the destroyed ice giant. Its rotation may be altered, its axis tilted. The debris field from the collision forms a vast disk around the gas giant. Over millions of years, this debris coalesces into new moons, some perhaps large enough to be considered planets themselves. Cosmic Echoes: Searching for Evidence. These collisions are rare, but they leave behind telltale signs. Astronomers are searching for these signs in other star systems. They look for gas giants with unusual compositions, tilted axes, or rings of debris. They also look for planets with highly elliptical orbits, evidence of a past gravitational disturbance. Each discovery brings us closer to understanding the dynamic and chaotic history of our universe. Planetary Jigsaw: Understanding our solar system. Studying planetary collisions helps us understand our own solar system. Some scientists believe that a giant impact early in Earth's history led to the formation of our moon. Others believe that Jupiter's immense gravity has shaped the asteroid belt and influenced the evolution of the inner planets. By studying these cosmic events, we gain a deeper appreciation for the forces that shaped our world. Life, the universe, and everything: Implications for life. Planetary collisions are destructive, but they can also be creative. They can deliver water and organic molecules to otherwise dry and barren worlds. They can create new environments, new possibilities for life to emerge. The universe is a vast and wondrous place full of mystery and potential. By studying these cosmic events, we gain a deeper understanding of our place in the cosmos and the conditions that make life possible. The never-ending story: The Future of Planetary Collisions. The universe is constantly evolving. From the smallest particles to the largest galaxies, everything is in a state of flux. Stars are born, they live, and they die. This cycle of stellar life and death is a fundamental process that shapes the cosmos. Planets form from the dust and gas left over from star formation. They collide, merge, and sometimes are torn apart, only to be reborn in new forms. The dance of creation and destruction continues. Supernovas scatter elements across space, while collisions can give birth to new planetary systems. In the far distant future, our own solar system will undergo dramatic changes. The forces that have shaped it for billions of years will continue to do so. The Sun will expand into a red giant, engulfing the inner planets, including Mercury and Venus. Earth's fate in this scenario is still a topic of scientific debate. The outer planets will migrate, their orbits shifting due to gravitational interactions. This could lead to potential collisions or the ejection of planets from the solar system. But for now, we can marvel at the beauty and chaos of the cosmos. The night sky is a window into the past, showing us light from stars that have traveled for millions of years. We can study these events and learn from them. Each observation helps us understand the complex dynamics of the universe. And we can continue to explore the universe, searching for answers to the biggest questions of all. How did we get here? Are we alone? What is our place in the cosmos? How did we get here? Are we alone? These questions drive our quest for knowledge and exploration. And what is the fate of the universe? Will it continue to expand forever, or will it eventually collapse back into itself? These are the mysteries that keep us looking up at the stars.